survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes in the supermarket with a standard deviation of 12 minutes. The length of time in the store is normally distributed. They have to tell us that because we have to know that it follows your normal curve. And x is represented and is represented by the variable x. That's what's changing, the amount of time in here. A shopper enters the store. We want to find the probability. This is going to be the area under your curve, that the shopper will be in the store between 24 and 54 minutes. And then we want to use that probability to predict if 200 shoppers then entered your store, how many of those 200, according to the statistics we just developed, would you expect to last in your store from 24 to 54 minutes?
Use each of those as each your x's.
Yes. Exactly what we're going to do. Because you know the in between says you have to subtract your areas of your z-scores, right? Now, let's follow this normally. Let's pull out your standard deviation and your mean. It's 45 minutes. I have to move this up so I can see, so we have some space to work. Now, I told you the first thing, create a probability statement. You want to know what is the probability of them being there between 24 and 54 minutes. So how do I write this probability statement?
G 24x.
Good.
Oh yeah.
Less than x. Good. Very good. This is the probability statement I want. What is the probability, my area under my curve, between those two z-scores that I'm about to find? And that will tell me the probability of somebody staying in there between 24 and 54 minutes. Now, if you were to guess, knowing that the mean is 54, would you say this is a high probability or a low probability? A high probability, right? Where's your mean? Your mean is at 45. So you're a little on the left, you're a lot on the left, you're a little on the right. So let's sketch this out. This is why your sketch is important. Everybody do this with me. Put your standard deviations on the bottom. If you guys get this part, it makes life so much easier every time you do this. Now, your mean, median, and mode ends middles. So we start up here, 45. I want your sketch to look like this. Add 12. Just keep adding 12. 57, add 12 more. Add 12 more. So now we know where we're going with this, where my x values are going. Then you're going to go down the opposite way. You're going to subtract 12. So now we know where our minutes are. So we can see if x is 24, we want approximately from here somewhere to 54, approximately from here. We want this big chunk, and as Oliver said, that looks like it's going to be a good size probability. Isn't that a big part of my curve? A very big part of my curve. So now, Nick also said we've got two x values. We've got when x is equal to 24, when x is equal to 54. So we're going to convert your x values to z-scores. Because remember when you use z-scores, you took the z-score, you found the areas, and you subtracted your areas. So now we use your formula. Another thing that sketch helps is for this. On the 24, is the z-score positive or negative? Negative. So I have to subtract my smaller minus my larger. And I can't tell you how many kids always go for the positive. So use that to help you. Divide by your standard deviation. Oops, this should say z. So now my z-score says subtract, divide by 12, and your z-score is negative 1.75. You know what? Let me see if it fits my table. Look at where your z-scores are in the bottom. Is it between, is negative 1.75 between the negative 1 and the negative 2?
Wait, I thought you wanted to do the bigger value.
No, that's only for area. Only when you're subtracting your area. When you're finding your z-score,
Yeah,
we have...
you said for even if you're finding the z-scores.
No, not the z-scores, only the areas.
So
When
it's just...
the areas, it doesn't matter what the z-scores are, we always subtract the larger area minus the smaller area.
I understand it, I'm just saying it now. So you're finding z-scores, it's just strictly mean subtracted
No,
by value.
it's
What is
x,
value?
x minus the mean all the
The
time.
value is subtracted.
X value minus the mean. What happens is this. Your x value is smaller
I
than
think
your
that's
mean.
why I messed up last night.
Okay. Because we're combining everything, so you're right. A lot of things kind of like overlap a little bit. So now let's find the z-score for this. Now, 54 should have a positive or negative z-score?
Positive.
Positive. So I subtract the larger minus the smaller. X minus the mean. I do this side. 0.75. Thank you. Now, 0.75. Wow, that does fall between the 0 and the 1. Right? See how it makes sense? Now, okay, now this is where we were before on the last unit that we did. We had the z-scores, we found the areas, and we subtracted the areas. So pick up your table 4. 0.7734. And the negative one is what?
You have to do one minus that?
No, you're finding the area to the left.
0.040.
So, Damani, here is where we always subtract the larger area minus the smaller area, because areas can never be negative. So this guy comes out to be 0.7333. And we said that would be a very good size probability. It's in the middle of my curve. It's a good chunk of my curve. Now, here is a good spot to turn this into a percent, because what does this mean to me? The probability that they come in my store and stay between 24 and 54 minutes? It's 73%. If I took a random person, they have a 73% chance of staying in my shopping center between 24 and 54 minutes.
Pretty good.
Yeah. Well, you figure yourself, even if you run in for 1 or 2 things, usually ends up being in there at least 20, 25 minutes. Because first you find a couple of other things, you find a few more things. So 24 minutes is not a long time to be in a shopping store. You got to find your items, you got to be online, okay? So if there's a 73% chance that a random shopper will be in my store between 24 and 54 minutes. Now, the next part of this says, if there are 200 shoppers, that are about to walk in, if I use this probability, I want to find out how many of those 200 will stay in my store between 24 and 54 minutes. So to find out that, I take this 200 and I multiply it by this probability. You might as well leave that in a decimal, because your percent should have to turn back to a decimal.
Is that n?
N equals 200. So you get 146.66 shoppers. And could you have a partial shopper? No, so we're going to round. We're going to say 147 shoppers out of the 200 that just walked in will stay in my store between 24 and 54 minutes. Make sense?
Where did the 200 go?
The 200 came from the problem. If you look in your book, part B, said if 200 shoppers enter the store, if I bring it back up there, I'm going to lose this. If 200 shoppers entered your store, how many would you expect to be in there between your 24 and 54 minutes? So this is a prediction. We're making a prediction of what's going to happen. And we can, according to what we looked up, we can say about 73% of those shoppers will be in there that long. Yes?
So no matter how many minutes it's in, all you have to do is take that percent and number how many people.
That's how many fit that scenario.
So 30 to 50.
Well, 39 minutes is different. We're going to do it for 39, more than 39 minutes. This is separate. This is a separate part. Yeah, that has nothing to do with this part. So,
Yeah, that's what that.
We found your mean, we found your standard deviation, we laid them out on the curve, we made a probability statement, we found the z-scores related to those x values, and then in between, we found the areas and subtracted your areas. Okay, now, for those of you that love the calculator steps, Nick, this is really nice on your calculator. You like the when you're using the calculator yesterday? Whoops. I just moved my calculator. Now, this works really nice when you have an in-between. It works even nicer when you have your x values. So second verse. Oops, if I turn it on.
Our low would be like 24.
Your low is 24. Normal, CDF. Your lower limit is 24. What's your upper limit? 54. Now be careful. Your mean is not 0 anymore. What's your mean? 45. And what's your standard deviation? 12. So then it gives you your area. Your area under that little piece of curve. Your probability. So by doing that, you bypass this whole section right here. And you bypass subtracting those areas. You bypass that whole thing by doing that. Pretty nice, right? Now, that normal CDF will let you use a z-score as an upper limit and a lower limit. If your mean is 0, your standard deviation is 1. It lets you use an x value, but then you have to put in your mean and your standard deviation. If you can't use it, don't worry about it. You can always use this. And I prefer you at least give this a good try first so that you know where you're going with this. Okay? All right, let's try the next part of this.
I would have tried to calculate things would work on the homework too.
Absolutely.
Those numbers.
Yeah, absolutely.
Wow.
Okay, we've got the same thing, 45 and 12. Unfortunately, I'm going to have to make my curve all over. It's the same curve. Okay, same curve. But now we want to know what is the probability that a random shopper will stay in there for more than 39 minutes. So, what's my probability statement going to look like?
Less greater than 39.
Good. X is greater than 39. So, I find 39 minutes, and my 39 minutes is over here. Is my z-score going to be positive or negative? Negative. It's on the left of the 0, right? And I want more than. So where's my arrow pointing? To the right. So this probability going to be a good chunk? Yeah, because it's more than 50%, right? A lot more than 50%. So now, let's find your z-score. Same thing. So this is where we say to mine, if the x value is less than the mean, it falls on the negative side. So I subtract my smaller minus my larger, divide by my standard deviation. And you should come out with negative 0.5. And isn't it between the 0 and the negative 1? Guys, I hope you're writing this down. You need to write this down. Okay, now, what's my next step? Go to the chart.
Find what negative 25 is.
Find where negative 0.5 is. Hang on. Find where negative 0.5 is. And what's your area for negative 0.5? But that's not greater than 50%, is it? It's not. See, you do 1 minus this guy. Good, because that's what my graph helps me determine. We thought it was going to be more than 50%, and it's true because I got the area to the left of that, and I had to subtract it from 1. And so here's my probability. I have 69.15% chance that the next person I check at random will be in my store more than 39 minutes. Now, Another way to look that up is go to the positive 0.5,
And subtract.
Yeah, you don't have to stretch.
and you don't have to subtract it because isn't it symmetric about the mean? So now if I'm on this side, it's a little harder to visualize when you're going across the zero. It's kind of like one of those reflections in geometry when you have to go over the axis. And then you look that up, and that would be this one. God bless you. Good? Yes. Okay, I want you guys to try it too. Try this. It's using the same curve, it's using the same information. I want the probability that the shopper will be in the supermarket between 33 and 60 minutes. Okay. What's your lower limit? 39.
Oh, and then the upper is
999. Now, the only no. Oh,
No,
oh,
no.
good.
what's the
Yes.
Oh, your lower would be negative 999.
You want to be between. I'm going to use the same graph between 33. Maybe, and you know that the negative one is there, and 60. And you want this whole chunk. So again, you want a pretty good size probability. So do I have to find a z-score for 33? I can. I'm still going to find it to be 33 minus 45 over 12, 12 over 12, negative 12 over 12. You got a z-score of negative 1, which I can find from my chart. Do the x value of 60. Find your z-score. Is that z-score going to be positive or negative? Positive. And that z-score is what? 1.25. Thank you. And did it fall between the 1 and the 2? Yeah. See how nice your sketch helps you? Yeah. To find the area, we know once you hit your z-scores, you look up your z-score areas and you subtract your areas. So you find your areas for these guys. The areas. So we're going to plug all you guys. So you got 0.1587 and 0.8944. You always subtract so that your area is positive. Because you never can have negative area under your curve. So what this means is the probability that the next random shopper, a random shopper that we pull, will last about a 74% chance that that shopper will last between 33 and 60 minutes in my supermarket. Now, if 200 shoppers enter my supermarket and we follow this pattern, we will predict that about 74%, 73.57% of the 200 will stay between that amount of minutes. So we multiply 200 times 0.7357 and you round.
In the book it says 150.
Oh, they changed it to 150? Thank you. In the book it says 150. Yes, thank you. So they're the next 150 shoppers that walk in. How many of them, based on this data, will last from 33? And you got 110?
I got 110.
50 minus the 10.
I got 110. Try it again. Multiply this number by 150. And you'll get 110.3 something or other, so round down to 110.
I didn't get that too.
You didn't get this number, 0.7357?
I didn't get that 110. I didn't get the 1587.
Oh, at your negative 1?
Yeah.
So in your table, when it's negative 1.0, come all the way over here to the 0, 0. It's backwards. It goes 0.09 all the way to 0.00. Don't take the first column. You might have taken the first column. Because that messes me up all the time.
Wait, what do you mean?
Look across the top of your graph.
Oh, I'm looking on the side.
Oh, okay. You have to be on the negative side. Okay. Does this make more sense? All right. See if you could. All I want you to do is the problems you did last night. Just see if you can make sure you can understand how to do them correctly. If you didn't know how to do them, make sure now you can do them correctly. go through those, and then we'll go over the other homework out on Monday.
Cheers.